Hey guys, in this video the lovely Mr. B is going to be taking you through the equation of a circle and all the things that we can do with circle lines. He's going to work you through lots of examples nice and slowly, but if you want to do practice questions to ensure that you've properly mastered this skill, then they are all waiting for you over on my website.
We are going to have a look at the equations of circles and lines that are related to circles. So our first question, we're going to find the equation of a circle with centre 6, 9 and radius 4. So the key thing here is, firstly, we have this centre. We have an x and a y coordinate, and they correspond to a and b in the circle formula. So we write out the circle formula. It's going to be x minus a, which is 6, all squared, plus y minus b, which is 9, all squared. So the first part of the formula is about where the centre of the circle is. Then we have the radius being 4. So this is the r part of the formula. So we can say that this is equal to r squared or 4 squared. And you can leave it as 4 squared, or what you might want to do is then actually do 4 squared to get 16. So the equation of the circle is x minus 6 all squared plus y minus 9 all squared is equal to 16. If you substitute in values of x or values of y, then it's going to give you the other points on the circle. So for example, let's say we want the part of the circle where the x coordinate is 5, substitute that in, and then we get the y coordinate out for the place where x is 5. And you might even get 2 answers for that, because with a circle, you might have 2 places for each coordinate. Now, if we sketch a circle to see how that will work, it's going to be a really quick sketch here. So let's say we want the place where x is equal to 5. Then we look at the circle, you're going to have a place at the bottom of the circle x is equal to 5, and a place on the top of the circle where x is equal to 5. And so that's what the kind of squared part of this does, where it gives us 2 potential answers. And the same thing with the y coordinates as well. So let's say we wanted a y coordinate of 3, then there would be 2 places on the circle where y is 3. So you substitute 3 in, you work out the formula, and then you can have an x coordinate come out. But you'll have 2 x coordinates come out for the 2 different places where y can be 3. For our next example, so we've got a point on the edge of the circle, 9, 5, and then we've got the centre of the circle, 5, 7. So we write out the equation. It's going to be x minus a. Let's look at the centre. The x coordinate is a. The y coordinate is b. So that'll be x minus 5 all squared plus y minus 7 all squared. And it's going to be equal to the radius squared, but we haven't been given the radius. We've given a point on the edge of the circle. Now let's imagine we had a diagram. So with our diagram, we would have the center of the circle, 5, 7, and we have the point on the edge of the circle, 9, 5. Now, between the center and the edge of the circle, that's going to be the radius. So what we actually have to do here is find the length of the line. Now, look at the x and y coordinates, x1 and y1, x2 and y2. Look at the difference between x1 and x2. So that's going to be a difference of 4 from 5 to 9. Then look at y1 and y2. That's a distance of 2 from 5 to 7. So we've got a triangle here because the x and y coordinates and the axes are going to be at a right angle to each other, so right angle triangle. So we can use Pythagoras theorem to find the radius. So it's going to be 4 squared plus 2 squared, or rather the square root of 4 squared plus 2 squared to find Pythagoras theorem here. That's going to be 16 plus 4, which is 20, so it's going to be the square root of 20. Now, if the radius is the square root of 20, the radius squared, you square both sides, the radius squared is going to be 20. So in our final answer, we can just write in the 20 at the end. So we don't need to put a root into our answer, because having to put the radius squared in means that any root is going to be cancelled out. So our final answer is x minus 5 all squared plus y minus 7 all squared is equal to 20. Looking at the next question, so we've got a centre, 6, 5. So that's the A and B in our original formula. And then we've got a point on the edge of the circle. So we can start to write out the form of the circle. It's going to be x minus 6 all squared plus y minus 5 all squared, and it's going to be equal to the radius. So again, the best thing to do this is think of it as a triangle. So look at the differences in our x coordinates. We've got 2 and 6. So our x coordinate is going to be a distance of 4. Then look at the y coordinates. We've got 5 and 0. That's going to be a distance of 5. The x and y axes are at a right angle to each other. So again, we can use Pythagoras theorem. That's going to be 5 squared plus 4 squared and the square root of the whole thing. So altogether, that's 25 plus 16, which is 41. So it's the square root of 41. So like with the last question, if the radius is root 41. The radius squared, which we need for our formula, is just going to be 41. Now, the difference with this question is it doesn't want it in this form. It wants it in a different form. It wants it in the form ax squared plus bx plus cy squared plus dx plus e is equal to 0. So one way to figure this out is to actually expand the brackets. So let's expand the x first. X times x is x squared. Then we'd have x times negative 6 twice, which would be negative 12x. And negative 6 times negative 6 is going to be 36. So that's the first bracket. Now let's look at the second bracket. So we're going to have y times y is y squared. Y times negative 5 is negative 5y. There'll be 2 of those. And then negative 5 times negative 5 is 25. Then we want it to equal to 0. So we want to take the 41 away from both sides to make it equal to 0. And once we've done that, we can now start to collect up our terms. So we want ax squared. So that's going to be 1x squared. Then we want bx, so minus 12x. Then cy squared, that's 1y squared. Then plus dx, that'd be negative 10y, which we have made a mistake writing out the formula. That should be dy. Then we need to collect up the whole number terms. We've got 36. We're adding on 25 and we're taking away 41. So that's going to be a 20 left over. So there we have the equation of the circle in the form we've been asked for. Now, I want to talk about the letters we're using here. Now, in the previous formulas, A and B were the x and y coordinates on the center. They don't have a relation to the A and B in this new formula. So when I said A and B at the start, I was talking about our formula for the last few questions, where it's x minus A squared plus x minus y minus B squared equals R squared. That's where this A and B is used. So the A and B in the other form doesn't actually follow the same pattern. So you'll see A in this case is 1 and B is negative 12. Just be careful getting confused with the letters. They do mean different things in this formula. So moving on to our next example. It's again probably easier to start off writing your circle with the original equation we looked at. We have x minus the x coordinate of the centre, which is negative 6. That'll be a double negative, which gives a positive 6. Then we have y minus the y coordinate of the centre. To take away negative 2, again double negative, it'll be a positive 2. Then that'll be equal to the radius squared, which we have to work out using Pythagoras theorem, since our clue is a point on the edge of the circle. We've not been given the radius itself. So thinking about our triangle, so the x-coordinates were negative 8 and negative 6. That's a distance of 2 between them. The y-coordinates negative 4 and negative 2. Again, that's a distance of 2 between them. So that's going to be the square root of 4 plus 4, which will be the square root of 8. That means we write 8 at the end of our formula. Then let's expand the brackets for the form being asked for. So that will always give you the first term squared. The middle term could be x times 6, but when you expand the full set of brackets, you'll end up with that term twice. So that'll be 12x, and it'll be 4y. Then you want the number value squared. So 6 squared is 36, and 2 squared is 4. And then take the radius squared away, so it's equal to 0. Then collect up the terms. So we have a 1x squared plus a 12x plus a 1y squared plus 4y. And then add up the number terms. We've got 36. We're adding 4 and we're taking away 8. So that's going to give us 32. There we have the equation of the circle in the form we've been asked for. The last example like this, a little bit more complicated. We've been given the point on either side of the diameter. So we've not been given the point at the centre of the circle. Now we can find that the centre is in the middle of the diameter, so we can find the midpoint. So let's have a look at the x coordinates first. So we're going from 4, 7, and then that's going to 10, 5. So looking at the x coordinates, 4 and 10, to find the middle of those, add them together, divide by 2, you find the average of them, and we get 7. The halfway point, the coordinate is going to have a 7 in it. Then do the same thing with the y coordinates. We've got 7 and we've got 5. So let's find the average of them. So 7 plus 5, all divided by 2. 7 plus 5 is going to give us 12, and divide by 2 will give us 6. So the midpoint, the centre of the circle, is at 7, 6. So let's start to write out the equation of the circle. We're going to have x minus 7, and we're going to have y minus 6, all squared. Then we want the radius. Again, we've not been given the radius. Now, there's a few ways of doing this. Again, we're going to have to use Pythagoras theorem. You could do it for the diameter, and I think I'll do it this way, or you could do it for the radius that we did for the previous two. Now, if we do this for the diameter, Pythagoras theorem, from 4 to 10 is a distance of 6, from 7 to 5 is a distance of 2. That's going to be 36 plus 4, which is the root of 40. Now, that's the length of the diameter. The diameter is the square root of 40. The radius is going to be half of that. So that'd be root 40 over 2. Now, we can use our surd skills here to do some simplification of root 40 over 2. So we could turn root 40 into root 4 times root 10 all over 2. And root 4 is 2. So we can do the 2 divided by 2, which just leaves us with root 10. We'll go back to our formula. If the radius is root 10, then in our formula, we just write 10. Alternatively, you do it the same way as we did previously. Let's just do that just to double check. So we want in between, let's say, the 4 and the 7 is the distance of 3. The 7 and the 6 is the distance of 1. So that'd be 9 plus 1, which is root 10. And I think actually going straight for the radius using the centre and one of the coordinates at the end is a lot faster than taking half of the diameter. If we take half the diameter, it's not as simple as saying, well, it's half of root 40, which is root 20. That'd be the incorrect answer. As you can see, the answer was root 10. You have to use some surd manipulation to divide it by 2, actually. Now, once we've done all of that, we have to get it into the form we've been asked for. So to do that, we are going to have to expand the brackets. That will give us x squared minus 14x. Let's look at the y's, because we're going to go straight to the answer of y squared minus 12y. And then with the number terms, we'll have negative 7 squared, which is 49. Add on to that, negative 6 squared, which is 36. And take away the radius, which is take away 10. So that's going to give us 75. So you can see, compared to the previous question, what I've done is I've skipped a step in the middle and gone straight to my answer, which is something you can do once you start to get more confident. Now, you can also have questions where we work backwards. We want to find the centre and the radius of the equation we're given. Now, the centre is the numbers in the brackets, and the radius is related to the number at the end. Now, for the centre is going to be 8, 9. So where does that come from? So it's just kind of the negative version of what's in the brackets. Then we want the radius. The radius is the square root of the number at the end, root 49, which is 7, which is the radius. So again, just the opposite of what we've been doing before. Moving on to our next example, I want to find the centre first. So look at the numbers in the brackets, and you want the opposite sign to them. So the x is not going to be plus 2, it's going to be negative 2. Or the y is not going to be negative 1, it's going to be a positive 1. Then look at the radius. The radius is the square root of the number at the end, with the square root of 25, which is 5. And looking at one more example, again, I want to find the centre. Look at the numbers in the brackets, label what you're finding, and we want the kind of reverse of the numbers in the brackets. Negative 5 will be a positive 5, and positive 6 will be a negative 6. When we look at the radius, it's the root of the number at the end. So the radius is going to be the square root of 169. You can leave the answer like that unless it's actually a square number. In this case, it's 13. 13 times 13 is 169. But again, it's not a square number. Leave it as a root, leave it as an exact answer, unless you ask for a decimal, and then you can round it. Where this gets harder is when we have the alternate equation for the circle. And what we want to do really is get it into the brackets, because the brackets was nice and easy to read the answers out of. So let's have a look at the x values first, and then we can look at the y values. Finally, we can look at the radius. So with the x coordinates, to factorize that, it's going to be x minus 6. So essentially, we are completing the square here. And then we're going to have the negative 6 is going to be multiplied out. So the negative 6 multiplied out is going to give 36. So we need to take that away to cancel it out. Then we're going to complete the square for the pink section for y. That's going to be y minus 2 all squared. Again, we have the negative 2 squared is 4. That's an extra bit we didn't ask for because we didn't actually take into account a plus 4 here. So we have to take away that 4. And then we've got the plus 31, and it's all equal to 0. Now, what we actually want with this is we want the kind of the x bracket section, and we want the y bracket section, but we want the numbers to be kind of on the other side. So let's collect up the numbers on the left-hand side first. So negative 36, take away 4, and then plus 31. That gives us negative 9 on the left-hand side. So we add 9 to both sides. Now it moves to the right-hand side. And now we've got it into the format we're used to. So we can look at the centre. The centre is going to be 6, 2. And we can look at the radius. The radius is going to be the square root of 9, which is 3. So essentially to get from this format to the other format, you need to complete the square and then collect up all the extra terms at the end. Then you can rearrange and find the centre and the radius. So let's have a look at another example. So we're going to factorize the x's, factorize the y's, and then collect up the number terms to get it into the circle formula. So complete the square for the x's, that'll be x minus 4. But if we do x minus 4 squared, it doesn't just represent the x squared minus 8x, because when you multiply it out, negative 4 times negative 4 will also give us a 16, which we didn't want. We need to take away that extra 16. This is completing the square. Same thing for the y's. So we want half the coefficient on the y, y, so the negative 10 becomes negative 5, but then negative 5 times negative 5 is 25. We didn't want that 25, we need to take it away. Then we have the take away 59, and it's equal to 0. So let's rearrange. X minus 4 all squared plus y minus 5 all squared, and then we want to start at the radius. So again, collect the terms on the left-hand side. We have negative 16, take away 25, take away 59. Altogether, that gives us negative 100 on the left-hand side. We want it on the right, add 100 to both sides, you get a positive 100. Now, very often, if you get something that won't, you can't get the square root of, then that's going to be a wrong answer, because we want to root to 100 to get the radius. The radius is going to be 10, obviously, but not always. Sometimes you can have decimal answers. So that's not always a sign you got it wrong, just a sign to check. Where you've definitely got this wrong is, if you get a negative number on the right-hand side, you can't take the square root of a negative number, so you know you've made a mistake for sure. So let's write down the final answers. The centre, look at the bracket, this will be 4, 5, and the radius is going to be the square root of 100, which is 10. So there we have our final answers. The last thing we'll look at are tangents to circles. Now let's look at the circle first. So we see the centre is related to the negative 6 and the negative 1 in the brackets. The centre is going to be 6, 1. Then we have a point on the edge of the circle, the point 3, 4. That's be somewhere like this. And then the radius is the square root of 18. So we can see how long this is. It's going to be root 18 in length for the radius. This is what we know about the circle. Now what we've been asked for is the equation of the tangent to the circle at the point 3, 4. Now what the tangent to the circle means is it's going to be a straight line that just touches the circle at 3, 4. So it's going to go through 3, 4 like this, touching the circle only at that point. And we want the equation of that line. Now, one point about the tangent is at a right angle to the radius. So if we can find the equation of the radius, then something at the right angle to it, that's going to be a perpendicular line. So the gradient is going to be a negative reciprocal if it's a perpendicular line. So firstly, let's find the equation of the radius. So I'm going to label which line I'm finding, because I'll have similar working out for both lines. I want to find the gradient first, which is the change in y over the change in x. So let's look at the change in y first. So we're going from a 4 on the outside to a 1 on the inside. So that's a change of 3. Now let's change in x. So we're going from a 3 on the outside to a 6 on the inside. That's a gradient of negative 3. So 3 divided by negative 3 is negative 1. Now, just make sure when you do this that you use the same coordinate for the x and y coordinates. So for the y coordinates, I started on the outside with the green point. So the x coordinates, I had to do the same thing and start with a point on the outside, the green point. That means that one gives me a positive number and one gives me a negative number. And by the way, you could do it the other way around. So rather than 4 take away 1, we could do 1 take away 4 and get negative 3. That means at the bottom we'd have 6 take away 3, which is a positive 3, giving us the same answer of negative 1. So now we can write the equation of the radius, or at least part of the equation of the radius. It's going to be y equals negative 1x plus c. And if we wanted to, we can substitute in the 3 and 4 and find c. Let's just do this actually. So y is 4, x is 3 on the outside, add 3 to both sides, and we get that c is equal to 7. So it's actually going to be y is equal to negative x plus 7. But we shouldn't actually need the c part of this, but let's move on. So we found the equation of the radius. Y is negative x plus 7. Now let's find the equation of the tangent. Now we know the gradient of the tangent because it's a negative reciprocal of the gradient of the radius. So what do you mean by negative reciprocal? So you do two things with a negative reciprocal. So you take your number as a fraction. So negative 1x, that's negative 1 over 1x. This is how you write 1 as a fraction. 1 divided by 1 is 1. If you want the negative reciprocal, we turn the negative into a positive, and we flip the fraction upside down, which in this case doesn't make any changes, but it will in future examples. So the gradient of the tangent is going to be a positive 1. So that's going to be y is equal to positive 1x plus c. Now again, substituting a point on the line, and again the point 3 falls on both lines, we can do that. So y would be 4, x would be 3. So if we take away 3 from both sides, c is going to be equal to 1. So the equation of the tangent is going to be y equals x plus 1. And that's our final answer. And what I'm going to do is sort of highlight it as well to make it really clear that this is our final answer, not the equation of the radius. So again, make sure the examiner knows which of the two equations you're saying is the final answer. Moving on to the next example, we've got a circle with centre, negative 10, negative 6. And we'll try and do this one without the diagram. So let's start out with the radius. What is the gradient of the radius? So the gradient is a change in y over the change in x. So let's look at the y coordinates. So for the y coordinates, we've got -6 at the center and -11 at the edge. And all we want to do is actually take these away from each other. So be careful of double negatives. We're taking away the -11. Then let's divide that by x. Let's look at the x coordinates. So with the -10, and then we're taking away the -15. Now you gotta be really, really careful with this. You'll see that the coordinates at the center, the -6 and -10, are both in the same spot. So if the center is going first, it's got to go first for x and y. You can swap the positions around and have the edge first, but if you have the edge first, then you have to have -11 and -15 underneath. You can't mix and match and have a center coordinate first for x, then an edge coordinate first for y. They've got to be the same way around. Now be careful of double negatives here. So -6, take away a -11. That's actually going to be -6 plus 11, which is going to give 5. That's over -10 plus 15, because the double negative, which again is going to give us 5. And 5 divided by 5 is 1. So we know the gradient of the radius is 1. Now we could go further at the last question and work out the entire equation of the radius, but we don't need it. We only needed the gradient, because now we can work at the tangent. We want the negative reciprocal of the gradient of the radius. So as a fraction, that's 1 over 1, positive 1 over 1. The negative reciprocal will be negative, change the positive to a negative, and then flip the fraction upside down. And again, for this example, that doesn't actually make any difference, but it will for the next few examples. So we know the gradient of the tangent is going to be -1. So now we can write out the equation at the tangent. Y is equal to -1x plus c. And now we can substitute in values for x and y. Now we've got two choices at the center, which is -10, -6. And we've got the edge, which is -15, -11. We have to use the edge here. It has to be a point on the tangent, and the center is not on the tangent. So with our substitution, it's actually going to be y, which is -11, is equal to our -x, with x being -15. So -15 is going to give us a +15, and then if we take 15 away from both sides, we're going to get that c is equal to -26. And so what we need to do now is go back to our formula, rub out the c, and put in -26, or even write it out again. So y is equal to -x, take away 26. And that's our final answer. So let's try the same thing with the next example. The center of this circle is going to be at 1, -1, and we want to find the equation of the radius first, or rather just the gradient of the radius will do. The gradient is the change in y over the change in x. Let's go with this center first. So y for the center is -1, and x for the center is +1. And we're taking away from that the edge. X for the edge is -3. And y for the edge is 2. That's going to give us -3 over 4, or -3/4. So that's the gradient of the radius. Now let's find the gradient of the tangent. This is going to be the negative reciprocal. So we have -3/4 for the radius. For the negative reciprocal, we're going to make it negative. That'll be a double negative, give us a positive gradient. And I'm going to flip the fraction upside down. 3 over 4 becomes 4 over 3. So in this case, you can see the negative reciprocal does actually change the number quite a bit. So now we can write down the equation. Y is equal to 4/3 of x plus c. And so now we need to substitute to find c. And we have to substitute the -3 too. We can't substitute in the center. The center is not on the tangent. Point on the edge of the circle is. So y2 is equal to 4/3 of x, which is -3, plus c. So 2 is equal to -12/3 plus c, and 12 divided by 3 is actually -4. So 2 is equal to -4 plus c. So we add 4 to both sides. That means that c is equal to 6. Now I can write out our final answer. Y is equal to 4/3 x plus 6. For the next equation, we're given different information, but this time we've just been given the center. So let's find the equation of the radius, or at least the gradient of the radius. So it's going to be the change in y over x. So the change in y, let's start off with the center. That'll be 4, and for x, 3. So let's take away to find the difference. At the point, y is going to be 2, and x is going to be 5. 4 take away 2 is 2, and 3 take away 5 is -2. So altogether, that'll be -1. For the gradient of the radius. Then we move on to the tangent. If the gradient of the radius is -1, then if we make it negative, it's already negative, so a double negative will become a positive, and flip the fraction upside down, it's not actually going to be a change. So we write out the equation between y is equal to 1x plus c. Then let's substitute in to see what c is. So y would have to be the 2 and x the 5. So we take 5 away from both sides. That's going to give us c is negative 3. So going back to our equation, get the plus c. I'm going to change it to a negative 3. So now let's look at our final example. Again, find the gradient of the radius first. Gradient always being the change in y over the change in x. So starting with the centre, y would be negative 10 and x is negative 5. We have to take away the edge. So it's going to be negative 8 for y and negative 4 for x. Double negatives will be a plus, so negative 10 plus 8 is negative 2, and negative 5 plus 4 is negative 1. Altogether, that'll be a positive 2. The negatives cancel out, and 2 divided by 1 is 2. So now we know the gradient of the radius, we know the gradient of the tangent, because it's perpendicular, so it'll be the negative reciprocal. So if we have a positive 2, then negative reciprocal will be a negative half. Flip the fraction upside down, and flipped the sign as well. So y is to be equal to negative half x plus c. Substitute to find c. Y would have to be negative 8. Again, we have to use the point for this. We can't use the centre. And x is negative 4. So negative half of negative 4, that'll be a positive. So positive 4 over 2, which is going to be a 2. So negative 8 is equal to 2 plus c. Take 2 away from both sides. Then c is going to be negative 10. So in our final answer, y is equal to negative half x take away 10.
Ouch! This is why in some videos I have unexplained scratches.